done speaking about that first homeostasis example, which looked a lot like this. So we were talking about this car, and the car had a set point value dialed in terms of its speed, which was about 60 miles per hour. And we said that the speed began to decrease when the car encountered the foot of this hill. And so that set off what we called an error signal. And then we also said that in order to begin correcting this error signal, that the car began to do something. This triggered an event which was increasing gas to the engine, and that would allow the car to begin to correct this initial error signal. And so after we had that happen, we began to see the speed increase to about 58 miles per hour. And then we started to see the error signal shrink, right? The error signal is going to be proportional to the degree or the amount with which we are away from the set point. So as it gets closer to the set point, the error signal begins to diminish. And then finally, when we get back to 60 miles per hour, the error signal is completely turned off because we're now back to our set point. So we were using this example to speak about the definition of homeostasis. And if you remember, we defined homeostasis on Friday as being maintaining a constant internal environment in the face of external change. And so this example kind of underscores some of the terms that are involved, such as set point and error signal, but we want to now begin to look at examples within our own physiology, right? Because we're not cars. So let's start to talk about some of the examples that we can see within our own physiology, as well as some of the other terms that are important for understanding homeostasis. So first off, we have the regulated variable. And the regulated variable is the aspect that's being maintained or that's changing from the set point, the aspect that the body is trying to get to stay at a certain value. And so some of the examples that we can think about for the regulated variable are blood pressure, body temperature, right? We know that our body temperature likes to be at around 37 degrees Celsius or 98 Fahrenheit. Blood pH should be around 7.35 to 7.45. And we've got blood glucose. There's a lot of different variables that we can think about. So those are some of the common ones that come to mind. So blood pressure, blood glucose, blood pH, and then body temperature. So you can kind of write those in on your slide. And so those are the variables that are examples of homeostasis within our physiology. Another important term is the set point. And this is the expected value of said regulated variable. So if we were speaking about blood pH, the set point would be around 7.35 to 7.45. If we're speaking about blood pressure, that should be around 120 to 130 over 80 to 90. If we're speaking about body temperature, we talked about 37 degrees Celsius. If we're speaking about blood sugar, that should be around 100 milligrams per deciliter. So these are the variables, or the values rather, that these variables should be maintained at, okay? And again, if you compare this to where disease process begins to creep in, this is when these set point values have been thrown off from where they should be. If we see blood glucose readings of about 140 and above, even in the 200s, we start to think about diabetes. Same thing for blood pressure. If we see that number go too high, this is where we start to see pathology or disease beginning to creep in. Okay. All right, so let's look at some of the other terms that are involved. Very, very, very important. I want you to highlight this one, negative feedback. So negative feedback is the self-correcting mechanism that's going to get our set point value restored, okay? So if a regulated variable decreases or increases, the system, which is the body, is going to make a change that's going to help bring that set point bring that value back to set point. And the mechanism that brings that about is called negative feedback. We also have positive feedback, and I'll talk a little bit about positive feedback, but it's not necessarily involved in homeostasis. The negative feedback is what is crucial to correcting that error signal. And then finally, the error signal, we introduced this term on Friday. This is the difference between our set point value and the value of the variable currently, okay? So again, think about blood pressure as that really common example. At the end of the day, your blood pressure is usually a bit high, and your body starts to bring about those restorative mechanisms to turn that error signal off and bring your blood pressure right back down to where it should be, to that set point value. Okay, so those are the four terms that are important when we speak about homeostasis. We've got the regulated variable, we've got the set point, we've got negative feedback, and we've got the error signal. Okay, so what I'm going to do now is we're going to look at an example of blood pressure, and then we're going to talk about those terms again and how they apply to this specific example. But before I do that, let's see if there are any questions. If you've got any questions, be sure to put them in the chat as we go along. I'll try to monitor this. Okay. All right, so we're looking at this blood pressure example. So we're going to look at how blood pressure changes with time. So we've got time here. And then we've got blood glucose. This is going to be in milligrams per deciliters. Now, as you mentioned before, we like to start at about 100. And in terms of normal physiology, healthy, 140 is kind of the upper limit here. So let's say we're starting off, we just had a meal. And so we start off with blood glucose at 100. And then after that meal, it's going to spike. And then over time, it's going to slowly return back to 100. Okay. And then we also want to point out the error signal. So as soon as we get this turned off, or as soon as we deviate from 100, we start to see this difference here. Okay. And then as we get closer to 100, once again, we see that difference diminish. All right. Now, what I want to do is I want us to define the terms relative or relevant to this example. So let's speak about the regulated variable. And so I want you to just fill that in. You're also going to fill in, for this example, what is the set point? Our third term was negative feedback. So based upon how we just described negative feedback, how would you define that relevant to this example? And then the fourth one we had was the error signal. So I want you to, on your own notes or on your own paper, write in what the definition or the description is for these terms we just described that are relevant to this blood sugar example.